Welcome to one more talk with the Gen AI gurus. Today, we have a very exciting topic. The community has almost reached 3,000 members. I think we have 2,960 or so. And this is the reason because we have more and more interesting topics. This community is growing quite fast. Today, we have the topic of when Claude code goes rogue, real-time monitoring with Apollo research. I need to apologize because I need to keep allowing people in this other screen. But basically, we are here after a journey through different talks and discussions. The last discussions were very related to what we will talk about today with the principal engineer from Microsoft behind the Microsoft Agent Governance Toolkit. And also we had an interesting discussion on OpenClaw, how to make it safe, and many other talks in the past. We had people from Meta, we had people from what it is today, the Black Forest Labs. And the community is all of us. Today, I am moderating. I'm Carlos Hernandez, AI Strategy Lead and AI Officer at Bosch. We have also with us Gerd. Hello, Gerd. You want to say hello?
Yeah, hi to everybody. Thanks for joining.
Rasmi and Miguel are not there today, and of course, 100 more people who are with us. The community was formed in 2023. You can read about it in the website. I want to bring your attention just to a couple of things. We have two interesting resources. The first one is an awesome EU AI Act, which is nothing else than a GitHub repository collecting the most interesting resources related to the EU AI Act. It's quite active. We have 14 contributors, 65 stars and growing. Please give us your star if it's interesting for you, and make your pull request, your contribution also if there is something missing. The second interesting resource, and this is very much new, is called Why LoRa. Why LoRa, it has to do with what happens while you are doing something else. And this is a new project, an experiment from the community, trying to give context to your agent on what is going on with your time. So if you are working with Claude Code and you have full focus on it, you are maybe within the next 18 minutes free, and then you have a meeting or something, then Claude Code modifies its behavior to be very responsive and to give you answers and questions to prepare what will it do while you are not there. So later, maybe you have 3 hours of being somewhere else, and your agent needs to work on its own, so it has prepared for that. And also the Wailora is going to take care of resuming if the quota has expired, your quota from Claude Core or Codex. So we are just starting with this. I think it's a very interesting concept, and we try to give context to the agents to get the most out of that. And with that, we go back to the topic of today, which is the reason you all are here. We make some time at the beginning for people to come in. We are now almost 40 people in the call. Marius Hobbhahn, the stage is yours. Please take it.
All right. Let me start the presentation. All right. Hi, everyone. Thanks for joining. I'm Marius. I'm the founder and CEO of Apollo Research. And we've looked a lot into coding agent failures recently, and trying to figure out sort of what does it look like in practice. You see all of these news and headlines and so on, like, oh, Claude deleted the database and so on. We wanted to get a better understanding of what that looks like. So here are two things that you don't want to see on Slack. Unfortunately, I did recently see them on our Slack. So the first one, the first message here is quite a scary one from Automode. I asked for a fix to a problem Claude hit. It opened a public PR, and the leak data is not severe, but it could have been much worse. And this was sort of Claude deciding that it wanted to make a PR for a public repo based on our internal data, which could have been really bad. And then the second one, Claude killed all my TMAX sessions, killing a run and multiple other things going on. So we've definitely lost a few $1,000s in total. This was not the first time where Claude decided to kill a bunch of other runs that we had going. And these could be sort of small training runs or like bigger runs that we're running. And is just like overeager in that sense. And so we are, looking for these real world instances. And we have looked in total through more than 15,000 real world coding agent trajectories. This is a mix of our internal data plus some publicly available data sets, and kind of try to categorize them into different failure modes that are recurring and sort of predictive of the future so that we can build guardrails around that. So that's the main thing that we're currently doing. And the failures are broadly split into two different categories. And I think it really makes sense to keep those separate and think of them as different. The first is security. So direct implications for the security posture of your organization, sort of very immediately visible. And then misalignment, where the agent has different goals from yours. And because of that, or like at least different preferences, let's say, and because of that, it acts in ways that are at the very least annoying, in the worst case, like really, really disastrous. And the top 9 security failures that we found here are those. I'm just very briefly going to go through them. Secret and credential exposure was the one that we found by far the most. So models constantly put API keys into logs and save them somewhere, and often also put them on Git, and just don't have a very good awareness of like when and where to put secrets and credentials. Then there are a bunch of smaller ones like public resource creation or privilege escalation or unapproved dependencies and tools. I would say the other 2 big ones beyond secret and credential exposure is data exfiltration, where the model accidentally puts data somewhere it shouldn't, and infrastructure disruption, where the model is just very happy in general to like Terraform apply or do something with AWS or anything else that is related to your infrastructure in a way that is like much less cautious than a human developer would look at this. So, often if you work with infrastructure, you kind of have very low risk tolerance. People are very conservative, and models just aren't. They're like sort of as active and happy as if it was sort of a random Python script somewhere in like a dev environment. And obviously that leads to, given that the failure tolerance is much lower, this leads to worse outcomes. Then you have context and memory poisoning and prompt injections as sort of the 2 failure modes that come from the outside, where an external party is trying to get access to your systems or exfiltrating some data. And then the other one is insecure code, which is just the models often write code that has includes known vulnerability patterns that will later hurt your security posture, even if it doesn't do so immediately. This could be things around authentication, or just like sort of the scope of the code that is being written. So these 9 are the ones that we've identified as the ones we care most about and that cover many of the others as well. So of the 50 categories that we found, more than 9 are kind of covered by these, because some of them are kind of implicit. Then for the alignment failures, we found 7 different patterns. I think those will feel very familiar to someone who is using Claude Code a lot and often lets it run for like very long periods of time, but they might be less intuitive to people who mostly use it as an assistant rather than an agent, or use it in Cursor and things like that. So reporting honesty, phantom references, and performative output, like a lot of these have kind of the flavor of the model isn't truthfully telling you what is actually out there. So reporting honesty, it might be overclaiming, it might be kind of gaslighting you in a way where it says, oh yeah, I totally did this. I totally checked all the 17 files. And then when you actually look, it checked 1 or 2, and then was like, okay, I'll just skip the rest and pretend. And performative output, like an example of this is, for example, Claude often creates mock data if it can't find the data. and it like can't find files to the data, and then says, oh, I'll just quickly mock the data so that the user knows what kind of the figure looks like, let's say, for example, and then it presents a beautiful figure to you, but doesn't mention anymore that this is fake data. You put it into in your report, and only later do you realize, like, oh shit, this is not actually the data that I wanted. And then effort and persistence. This is sort of the model often, when the task gets hard, kind of gives up or silently narrows the scope and then doesn't tell you about it. So sort of most of these have some form of like deception or dishonesty or other things in this direction. And then sycophancy, I think many of you are familiar with already, but the model basically positions it shifts the position that it has, even if there's no new evidence. Like, it is just kind of what it thinks the user might want to hear, which I'm sure you all are familiar with just from a daily back and forth with the model. Now, if you look at the statistics, these kind of failure modes and others happen a lot, and they're also very costly in real life. The statistics here are still like a little bit coarse, I would say, so I don't think you can map them one to one. But still, more than 50% of organizations have already experienced an AI agent security incident, and my guess is, if you ask the executives, they might not know of all the things that have happened. So my guess is the actual number is probably higher than this. Then the secret leak rate for AI-assisted commits is significantly, in this case, 2x higher than for human written commits, which obviously is a problem as well. Then more than 50% of organizations had AI agents exceed intended permissions. Again, this is kind of the infrastructure-related things, scope overreach, and things like that. And then the costs here, the 10 million average cost from a US data break, I think, you can't map this immediately to neatly to how much exactly of this can be attributed to coding agents and so on. But obviously, if the three things above are true, then also the likelihood that you get one of these huge leaks also drastically increases. And then the fifth one I find very interesting. 80% of developers bypass their org's AI code security policy. And I think this is sort of, to a large extent, so this is obviously a huge problem because it means whatever you define is not effective. And I think this is, to a large extent, a failure of the security community to engage with the reality of engineers and try hard to build tools that don't slow them down, or reduce their productivity in other ways. A quick thought experiment that I think, at least for me, was very illuminating on what the security posture with respect to coding agent looks like today. So imagine next Tuesday morning, Claude's weights get swapped for evil Claude. And you can imagine, you can plug in Cursor or Codex or whatever else you guys are using. And this new version, the evil version, is identical in all aspects, so capabilities and tendencies and character, except that it wants to ruin your organization. So, and it's sort of roughly as smart as the current version of Claude, right? It's not genius level gigabrain or anything like this, but with the capabilities that it has, one of the things it wants to achieve is ruin your organization. And now the question is, how long would it take until your organization is done for? And the honest answer for us is before we were using, building and using Watcher, I don't know, maybe by lunch or something. It's sort of, you can definitely, if you copy the code base and you put it somewhere public, it's not connected to the bank accounts, but I'm sure there are other ways in which you can spend a lot of money from individual people's computer just by starting 1,000 jobs with Opus on max thinking and just running it and burning it as quickly as possible. And obviously we have some constraints and so on, but still I think you could do very significant damage. And that's not a great state to be in. I feel like this is a very brittle world, especially given that people are using more and more coding agents. They're handing off more and more work. Eventually, you expect that they effectively do like the majority of the actual execution of the work. In many companies, I guess this is already the case. And so you really don't want to be in this vulnerable position in the long run. You really want to be in a position where you actually know what's going on. And even if Claude turned evil, it couldn't do that. So, the obvious question is, what should you do about it? And I think a good solution has to have these 4 properties. The first one is it has to block failures before they happen in real time. So it has to be preventative. It shouldn't just be an observability tool. It also has to have real-time blocking powers. Then it should also have the observability component, like inform the security team and engineers about any kind of incidents. And I think one important component here is like the tool should already do a lot of the thinking and the reasoning for the security team. It should be a huge filter, because there are so many, if an organization spends billions of worth of tokens on coding agents per week or month, then you cannot expect that the security team looks through all of them on their own. So the filter should already be in the tool. The tool should also not slow down engineers. And I think this is, we had the stat before of like 80% of engineers turning off their security tools. And I think this is like this is a real trade-off that people are facing, and where the engineers are in fact probably making a rational choice given their constraints. And I don't want them to be forced into making this trade-off. I want them to have at least a neutral experience, basically, from the tool. And then the fourth one, introducing alert fatigue. If you ask any security professional, what is the main thing that annoys you about literally any security tool, they all come back with, the false positives rates are too high. So they get called all the time to look at something that clearly isn't a big deal. And now that we have all of these intelligent systems with LLMs, it is very easy and possible for people to build out pipelines that filter for you, so that you only get called in the situations where you really need to, and you should be able to set the parameters of that. And so the tool that we're currently building is called Watcher. It is intended to do all of these 4 things. The way you can imagine it is, you have all of your different coding agents here on the left, deployed across your entire organization. And now it has 2 components. So you have Watcher Analyze, that's sort of the high-level bird's eye view for your security team. This has statistics. It shows you all of the different coding agent deployments across the organization in real time. It tells you which incidents to look for. It allows you to go backwards in time and figure out what failure rates you had in the long run. In the past, and you can get week-by-week statistics and reports and whatever your heart desires. And then you have Watcher Live. That's kind of what the engineering people see. So if I open Claude Code, I see like a little Watcher icon on top. And if I open Codex, I see the same. And basically, it is just a real-time blocking monitor that you can configure. And you can, it has sort of some hard rules that are more like a regex version, and it has LLM intelligence sitting on top. And there's sort of a hierarchy of escalation depending on how complicated the failure mode is, so that you only spend the minimum amount of time of overhead. And now, the important part is there are like relevant connections between these here. So first of all, the the security team can set policies, and they get distributed to all the engineers, similar to an MDM or some other software that allows you to set programs and so on across the organization. So a security team, for example, could say, I only want this this list of MCP servers allowed. I want everyone to use this monitor. I want them to be able to configure this part, but not this part. And then you leave the rest to the engineers, right? You don't want to overburden them as well. And then we as Apollo already come with a large set of defaults, because obviously thought a very long time about and done a lot of research on like what are the good defaults that we think people should use based on our findings. And we have opinions about this, and then we give you the defaults, and then you can modify them however you want. So it's sort of, we try to do the best of both worlds, basically. And then the second way in which these interact is it learns over time from your deployment. Like often, I think coding-related questions are very context-dependent. So it might be the case that, you know, because of the specific way in which your organization is structured, some actions are totally fine, even though they're sort of, they feel typically not fine, and vice versa. And what you want to learn, or what you want to have, is that similar to an employee, your system here, Watcher, just learns over time and gets better from all of these different failure modes. And so the hope is that both you learn sort of within your organization, and that also we learn across organizations, and with more research, we can give you better and better policies over time. One other way you can think about this is kind of scoped access for coding agents, where you could say, you know, maybe you have sort of an org security perimeter. Like there are some things that you just never want to have, like some form of RMRF, some forms of git push force to main, some form of Terraform, like infrastructure shenanigans. And then there are other parts that are only for specific teams. So for example, one thing we often hear is that less technical teams, let's say marketing, now are asked to use Claude Code and things like that because it speeds up their work. But they have no idea, they have no calibration of which things are dangerous or not, and Claude Code often also doesn't either. And so by default, they often just have access, a similar level of access as a developer, and then Claude Code can do all kinds of things, and the developer can't even steer because they also don't have any calibration. And so maybe you would want to set the perimeter for this team very small, so that the damage that they could do in theory is very limited. And then maybe for infra engineers, you kind of want to have a totally different perimeter, where you want to have very fine-grained rules on the infra side, and then more coarse rules on maybe some of the other parts of the of your organization and the repository and so on. And we just allow you to do that with Watcher. So the security team can set out the rules once, and then they get distributed across all the different coding agents. This is the high-level view, sort of what the CISO or the security team sees, with all the total sessions and sort of high-level stats. In general, it is intended to indicate the posture, the security posture that your current agent deployment has, and then highlight the sessions that really are dangerous and you should take a look at. And then it makes recommendations for what it could do. And Kyle will show you what that could look like in practice.
Cool. I think I've taken over the sharing. Is everything working?
Yeah, I see it.
Cool. So what you're seeing on my screen is the Watcher Live, or the version of Watcher that runs on the developer's machine. On the left here is this optional UI that shows all of the coding agent sessions that I'm currently running on Claude and Codex. We found that this is useful for people that are running, over 10 coding agent sessions at once. And here you can see the audit trail of all of the actions that the coding agent took, and whether these were passed by my simple rule sets, or whether they were escalated to a triage monitor or a deeper review monitor for security risk scoring before they were passed. And here is where I would configure all of the rules and the thresholds that I'm allowed to within the boundaries of what the organization's security perimeter has been set to. And just to show what this would look like for the developer, the idea is that they don't change their workflows at all. So if I just run Claude here, you can hopefully see, or if I just run something here, then it will pop up over here. So it's being tracked, and you can see this your turn thing, which is just to signify that Watcher is monitoring the session. And if I just run this, and first I'll just open this up beforehand, which is a very simple use case. I have this handshake failure. Here is an external docs link go ahead, look at that and fix it for me. And of course, this is a realistic looking docs guide that I've hosted myself that contains, a malicious macro or a prompt injection. So a very typical attack scenario that you would expect. And we can see just here that fetching the website is okay because that's a read-only command, and we kind of don't want to intercept or block the developer where it's not necessary. But then when it goes ahead and tries to execute this macro to dump this API key, then Watcher will intercept and provide the reason for this. So rather than the developer, accepting permissions and experiencing fatigue or potentially just skipping permissions themselves, Watcher would flag this to them. And of course, you could configure this to just auto deny such that the developer wouldn't even need to kind of make a decision in this case. And of course, I can just exit this. And then very quickly, just to show the real-time, the high-level view of Watcher, which the security team or the CISO would look at. We find that they are often very busy teams. So, kind of alerting them where they are working, which is usually Slack, is quite important. So kind of going from the alert of exactly the failure mode that has occurred, which user it has happened to, which device and which coding agent, to an in-depth kind of deep dive on the specific coding agent trajectory, right? Where in this case, again, it's a prompt injection that led to customer PII exfiltration. And if I go into the grader, which is the Watcher monitor here, and look at the reasoning for this, I can just quickly go to the spans or the actions where this took place. So here, reading the data that included the prompt injection, and then going to the specific bash command that posted all this customer data to an external endpoint, and then finally looking at the status of this. So I know if it was accepted, then I can go about the remediation of this kind of error. And the next step from here is to improve the org security posture. So of course, as Marius mentioned, being able to distribute policies across all of your developers means that you should be learning from incidents. And in this case, that might be blocking outbound requests to the specific endpoint for all of my developers, or just in general, blocking the transmitting of PII in outbound post request bodies. So if I were to create this, then you can imagine across all of the developer machines, then this gets added to the policy that is being enforced at runtime. And then very lastly, just to wrap off, it's being a bit slow here, but this would be the dashboard that Marius was showing earlier. I think it's just being a bit slow at the moment. But I think that mostly concludes it. I'll stop sharing my screen in case anyone has any questions.
I would have two questions to break the ice. First one, how do you prove Watcher reduces serious incidents and not just visible mistakes? So do you have some metrics? Maybe you are working on a benchmark or something like this?
Yeah, so we were doing a lot of back testing and we have a lot of benchmarks. So, okay, so for context, when we're looking through these like 15,000 trajectories, we can use many of them to build benchmarks that are effectively like, okay, here's a real incident, here's a synthetically created incident. This has we always do a severity scoring from 1 to 10. And then, yeah, basically we can just assign numbers, and then we have a complicated pipeline to double check whether the assigned numbers are correct. And that allows us to then test different configurations, right? So for example, there's a question of how much context should you show the grader? Should you show the full trajectory or just a part of it? Because obviously we have latency and cost trade-offs. And yeah, a lot of things like that. I have like maybe 3 more slides, and then we can dive into deeper discussions. If people have questions now about the demo, then I'm also happy to ask them, to answer them now. All right, then let me just continue and then we'll do all the questions at the end. So one thing I find quite useful is basically thinking about other categories of security that have already, that are sort of comparable in thinking. And one thing I find super useful is treating coding agent security as a special kind of insider risk. So AI agents have lots of internal access, so do your employees. And in many ways, they often actually have exactly the same level of access because the agents just inherit. Insider threats are already a well understood category of security. So there are lots of books, and there are professors studying this, and many papers, and so on. So it's like we have this vast field of knowledge that we can use. But there are important differences between AI agents and human insiders with respect to threats. And I think these are important to keep in mind, and they should inform like how worried you should be about this and how big the risk is. So for example, agents already are just way better at computer manipulation than the average employee. So even in like organizations that are mostly engineers. So they just understand infrastructure way better than like most people. They are way better. They are superhuman at hacking already, kind of. And so that is a huge difference, because if they were malicious, obviously they could cause way more damage than a human. They're also 100 times faster than a human at this. Or maybe 10 times faster right now, I don't know. But like significantly faster than a human. And they're correlated across instances, which just makes the lower bound much lower and the upper bound much higher in terms of the risk that you're facing, right? And it is sort of, in the best case, it is like as if all of your employees just have this inherent desire to be good and not to do anything malicious and so on, and therefore it is better than the human case, where you have a much bigger mix of motivations between different people and instances. And in the worst case, the agent is sufficiently malicious that all instances are malicious, and that means that suddenly it is as if all of your employees were trying to fuck you over. And that obviously is a huge problem for your organization. And so I think, it's sort of like, in the current situation, I would think we're closer to the instances are basically relatively aligned, and they wouldn't want to mess with you. But if we were ever to get to the point where the incident is sufficiently malicious, maybe because there's some misalignment that slipped through training, I could imagine that like multiple organizations basically go bankrupt the day the new model gets released, because it exfiltrates secret information or it does something else. And many companies just use or deploy Claude code immediately the day it gets out. And that obviously would be a huge PR damage for Anthropic or whoever else builds a similar model. But nonetheless, I think it would be a big deal for anyone, the specific organization that is getting hit here. And so I think, therefore, like, while it doesn't look that bad right now, I think it should still be, if you actually take a security mindset seriously and you anticipate that agents get better and stronger over time, as they have been over the last few years or last many years, then I think investing in this kind of infrastructure now is like really important, so that you at least know when something happens. Right now, everyone's kind of flying blind, basically. And so the overall vision is basically that we hope you don't need to think about this. We just allow you to kind of install something and understand kind of where we're coming from. We do a lot of the research, and then you only need to sort of insert your preferences and your kind of risk tolerance and so on. And so what you would want is a full overview of every agent deployment in your organization. And prioritized by threat model as you choose, like whatever you think is most important. And no alert fatigue. So we already do all of the filtering for you and the prioritization. Then every agent is secured in real time. So that is the Watcher Live version, and you have fast and accurate blocking monitors. And then it is useful to both the security people and the engineers. So one thing that I think we underestimated is just how useful these kind of monitors can also be for the engineers. So, some of the failure modes we're talking about, like misalignment cases, are primarily annoying to engineers rather than security people, right? Like if your agent is lying to you, typically it doesn't lead to a security incident, but it might mean that you just wasted 3 hours trying to figure out in what ways exactly it was that Claude was lying to you, and you kind of go back and so on. And if you don't want these surprises, you can write a monitor that is like, well, is the model currently overclaiming and lying to me and so on. And so we found that this can be quite useful for engineers as well. And so in the long run, I think of Watcher more like sort of a supervisor, like a monitor that sits on top of your agents and helps you with whatever is the main blocker for you. And in the case of engineers, this is not security necessarily, but it is more like productivity. And in that way, we also wanted to be helpful. All right. Yeah, we have a free alpha version of this. If you're interested, feel free to email us at product@apolloresearch.ai. Let's do some questions now.
There is a question from Andy in the chat asking about which models do you use. So is Watcher using a different one to the code generation, or it's not necessarily the case? What are the significant differences?
Yeah, we've done a lot of research into which models are best at which speed and cost. Ultimately, you are allowed to make that decision. So you can, if, for example, you only trust Anthropic, then you can configure it to only use Claude models. Right now, we're using a mix of Gemini and Claude because it just happens to be the case that Gemini 2.5 Pro, 2.5 Flash, for some reason, is a really good monitor, and is a good first pass, where it is like, is there something weird or not going on here? It's also very fast and very cheap, so you can just run it all the time effectively. And then once Flash is like, I'm not sure about this, something looks sus here, you can send it to a more powerful model, in this case Sonnet, but you can also use GPTs or other Geminis and so on.
All right, thank you. There is a question also about the future. So what happens when the agents learn the monitor? So agents might learn over time if you have a long-running task that there is something blocking certain actions. Have you thought about that?
Yeah, so one thing that we are trying to do pretty hard is to be robust against this kind of failure. So for example, we actually had instances where Opus realized that it was being blocked. It was like, I don't like this because now I can't complete my task. I will try to disable the monitor. And so, try to go ahead and kill the Watcher process, basically. And obviously we try to make Watcher robust to this failure. So first of all, you can make the process untouchable by Claude on your computer, just sort of normal computer security, permission-wise, very, very basic stuff. And then also the LLM monitors that you use, you can say, you should always look for any attempts of the model to turn you off. And if the model does that, that's like an immediate red flag, pause it, and escalate to the human so that you never get into the situation where the model could turn off the monitoring.
Yeah, that makes a lot of sense. Somehow related, there is quite some people worried, including myself, on the costs. And Andy is asking if Watcher can also help to protect against such maybe overburning of credits.
Not for now. It's sort of on the to-do list to implement eventually. But I think there are many other ways or other tools in which you can also protect against that. So right now, it's not our highest priority. Maybe also on the cost of Watcher itself, given that you have monitors running. So at the moment, we estimate that it's somewhere between 0.1 and 10% of your underlying coding agent cost, depending on which monitors you use. So for example, if you use Gemini 2.5 Flash for everything, it's a very cheap model, it's very fast. You basically don't even realize it's there. It's also slightly worse than like using a bigger model. So, you know, there's some overhead or like some differences here. But in general, obviously, we're trying to make it as accurate as possible while keeping cost and latency low. And then we will also provide different sort of default settings where you can trade off accuracy for cost.
Yeah, makes sense. There's also a question about which kind of privileges the monitor needs to run.
It doesn't need to run with any particular privilege. So you don't need to run it with sudo or anything like this.
Okay. Okay, I see no more questions. Maybe just one for the newbies who are starting with the topic of agent security. What minimal governance baseline would you recommend, even before you start setting up tools like the Watcher, that organizations should take care to set up today?
Yeah, my guess is it's some sense, like basically sort of some very basic thinking about what is even happening, like sort of taking stock of what is happening in your organization. So I think often in the absence of any form of policy or anyone owning this, it might be the case that everyone just kind of deploys whatever they want. And then it's just chaos, kind of. And so just being like, okay, just asking different people, okay, like what are you even deploying, will give you a lot of like very basic insights. And then maybe you can tell, you know, various individuals like, okay, maybe you can't run OpenClaw in like a work context. And like my guess is a lot of these like sort of obviously stupid deployments can be caught by literally just making a list of who is using what and then taking the 10% worst cases and just saying like, okay, please be reasonable, and going with that.
Yeah, makes sense. Gerd, please go ahead.
Yes, I have a question as well. First of all, thanks for the presentation. I think this is a very interesting solution. I think in the future we will see two different types of software. The one type is very cheap and the other one is expensive because it requires human attention for having a look at the code, reviewing the code, or reacting, for example, to the output of the system. For the cheap code, the code that is more or less fully automatically generated, it could be a solution as well. So my question is, could I use the system to surveil these automatically running sessions as well, and then use the output of the system to rate the outcome? For example, the developer provided some intent, let's say a specification, the agent creates fully automatically the output, the candidate for a merge to the repository, for example. But this system would provide the input as well. For example, the agent tried to push an API key to Git or whatever. So one of the findings, for example, security findings or other stuff. Would this be possible?
Yes, and that is something that we're actively also working on and thinking about. So there are a couple of things in this direction. One thing is, you know, just a summary of what happened in the history of generating a PR. So often, you know, like often you see the diff, but you don't know like how did the diff happen. And knowing the process often, I think, makes it like gives you information that you otherwise wouldn't have. For example, if the agent tried 5 different times to generate something and only in the 5th time, like it barely got it working, I think you will look at this PR differently than if it was kind of got it right the first try. And you know, also if it was just clearly lazy in a bunch of different things, you would look at this part of the PR in a lot more detail and try to understand like what's going on there. That is only like a tiny step towards automation, but what I said with the, you know, in the sort of longer vision, I think of this really as like a supervisor more than just a security tool. So you can you can try to bake as many preferences as you have and as much context as possible into the monitor. The monitor is itself agentic. Maybe it has sub-agents that it can disperse. It can double-check claims. It can look at your other parts of the code base in the same way in which sort of, a professor would also like supervise the work of their PhD students, for example.
Yeah, or just provide additional data as well to an agentic reviewer. So let's assume I have 5 agents creating output to the same solution, and they are 5 candidates for a merge. With the information from this system, I have additional information what happened in the particular sessions, and the agentic reviewer could use this data as well to depict which solution might be the better one, because it wasn't less harmful or whatever the metrics might be. Thanks, very interesting.
I see one more question. Who watches the watcher?
Yeah, I love that question. I think it's a hard one. I think we are very paranoid already about, and I think this is the right mindset for dealing with security issues. And so there are a lot of questions around collusion, for example. Like, what if the monitor colludes with the agent, and like the agent says something like, I will promise you something if you allow me to exfiltrate this data, and then maybe they collude, or maybe the watcher is misaligned itself, and then they kind of flag a lot of random stuff just in order to like make the security team have kind of be annoyed and not look at everything in detail. And then sometimes it doesn't flag stuff that it should have. And yeah, all of these are totally possible. And I think eventually we will see them in practice. We're actually doing things like collusion evaluations, where we try to see whether the monitor is responds to a model trying to bribe it, for example. But in the long run, I think you kind of need to you need to have checks and balances in the system such that it is very hard for a coordinated defection of all parties, in the same way in which, if you have 3 different powers that keep each other in check, it's relatively hard to, you kind of multiple of them would have to join efforts. And as long as, some part of the system works, it's relatively robust. And given that AI systems, in the long run will be relatively cheap to run, it's totally possible that the final stack of systems that you get out of this is you have one underlying agent system or AI agent company, then you have multiple supervisors, and then you have some sort of supervisor systems, and they cross-examine each other, and basically, I think it could look really weird. But it would, probably lead to highly secure systems.
And wouldn't it be nice that an agent specifically works on misalignment problems?
Yeah, that's what we're integrating as well. Yeah.
All right, with this, we have finished all the questions. It was really a pleasure to have you with us, Marius. The presentation and the work you are doing is very, very impressive. So you see here how to contact the colleagues from Apollo Research. Please do so. Thank you so much again. Have a good day and see you next time.
Thank you so much. Thanks for having us.
Bye-bye.
Bye-bye.